Hi, my name is Joseph Sanders, a student at Thomas Edison State College. My student ID is 0376295. This video is for Microcontrollers class, lab number 4. So what we're doing here in this lab is basically we're writing a program and running the software. We're programming the MCU, to basically apply real-world outside forces such as a toggle switch. So it's going to read our input-output device, which in this case is a switch that has several toggle switches on it. And basically what it's going to do is it's going to detect if a switch is on or off, and it will light LEDs based on what it senses. And so this program should just continuously run and detect to see which switch is on or off, and then light those lights accordingly. So I should be able to toggle switches on and off to light different patterns, and I'll explain that a little bit further here. So first I just want to say again, sorry, as with the other videos, sorry about the house. Still in the process of trying to get stuff moved. It's a slow process, but I'm going to turn this so you can see the board. Alright, so I've got the board hooked up, and I've got the dip switches set accordingly over here. Got all my connections made the way they're supposed to be. And then let's move over here. I want you to see I've got two windows open here. One is me showing that I've got the PIC actually programmed. And then over here is my actual program that I wrote. Okay, so I'm going to scroll down so you can see this. Alright, so this is the start of the program. I mean, it's pretty self-explanatory. Basically, we're setting RA0, RA1, RA2, and RA3 as our outputs for Tris A, and Tris B set RB0, RB1, RB2, and RB3 as outputs, and then the status shift to bank 00 for normal operation. And hold on, my other computer timed out on me. Okay. Alright, so what we're doing here, this is the beginning of the light loop. And what we want to do is make sure that our temp A and temp B are clear. So that's the purpose of that, to clear out anything that was there before or after it ran through the loop, or maybe before the program started. Alright, so at this point here, all we're doing is we're checking switch 1, here we're checking switch 2, and here we're checking switch 3. So if switch 1, if it detects that switch 1 it's on, then it's gonna go ahead and go to subroutine switch 1. Same thing here. If it detects switch 2, it's going to move to subroutine switch 2. If it detects switch 3, it's going to move to subroutine switch 3. Then let's go ahead and look at this. Alright, also part of that light loop is it's going to move temp A and temp B registers that were constructed depending on switch positions to port A and port B registers to display on the LEDs. Basically, all it's doing is it's reading this, and it's going to light the LEDs according to the instructions on each subroutine. So as an example, it's going to see here if switch 1 is set, it's basically sending a binary code or hex 9, which is 0000101 on port A. And so basically what that's doing is, think of it like this. This is starting from right to left. This is LED 1, 2, 3, 4, and that's on port A, and then LED 5, 6, 7, 8 is on port B. So for LEDs 1 and 4, port B doesn't matter because they're not. LEDs 1 and 4 are all on port A. So in this case, we want LED 1 and LED 4, thus you want 1001. Okay? And then the same concept goes for switch 2. We want LEDs 3, 5, 7, and 8. Well, as you can see, there's a 1 here. Well, if you can see it on the, there we go. As you can see, LED 3, there we go. As you can see, LED 3 has a 1 there, so it's going to light that, but that's on port A. We need to make sure that port B is detecting. So here on port B, LED 5, we don't want 6 to light, so that's a 0. And we do want 7 and 8 to light, so those are 1s. Let's see if I can move this down a little bit so you can see. And then for switch 3, we want LEDs 2 and 6 to light. So again, LED 2 is on port A, thus LED 2 has a 1, and all other spots have 0. And then we want LED 6, which is on port B, so we're going to light LED 6, 5, 6. So LED 6 has a 1, and all others have a 0. So for subroutine 3, then, in this particular case, if I can zoom in properly, zoom on this is terrible. Apologize about the focus. I'm still learning how to use this webcam. Oh, apparently I don't know how to focus on this thing. There we go. Okay, so anyways, for switch 3, LED 2 and 6 are going to light, as you can see in that. So basically, if I was to have switch 1 and switch 3 on, then I should get LEDs 1 and 4 and LEDs 2 and 6, but not LEDs 3, 5, 7, and 8. So let's test this and see. I've already programmed, as you can see. So let's move over here and check out these lights. And I'm going to turn on, I'm going to flip switch 1 up here. I'm going to flip switch 1, and according to our instructions here, switch 1 should light LED 1 and LED 4 and no others. So let's do that. Get in here so you can see. There we go. So you can see. Alright, turn it off. LED 1 and LED 4. Alright, so let's go to switch 2. This should light 3, 5, 7, and 8. As you can see, 3, 5, 7, and 8 light. Let me turn that one off. Switch 3 should do LEDs 2 and 6. And that's what it's doing. But what happens if I do LED 3, or excuse me, switch 3 and switch 1? Well, the lights that are currently lit are corresponding to switch 3, 2, and 6. If I also turn on switch 1, that should also light 1 and 4. So let's see if that's what happens. Indeed it is, 1 and 4. So now if I turn on switch 2, all LEDs should be lit, which they are. So I'll turn off switch 3, and that should turn off LEDs 2 and 6, which it did. Turn off switch 2, which that should turn off 3, 5, 7, and 8, which it did. And now we're left with switch 1, which is LEDs 1 and 4. Turn that off, and all of them go off. And there you have it. That concludes my video portion of this lab. I hope you enjoyed it. Thanks.